But right now we're going to bring on Jason Briggs. Jason is the Chief Technology Officer at J2 Innovations. And we are also joined by Gareth Johnson, who's the Senior Cloud Architect of J2 Innovations. They're going to be discussing Haystack Core TypeScript library. Gentlemen.
Hey everyone, this is Jason. How are you doing tonight or today, depending on where you are in the world? Yeah, what we built at J2 and Gareth's about to demonstrate is a TypeScript library for Haystack Core. He's going to demo everything. So what I'm saying probably is pretty boring right now, but it is exciting. J2's put it into production for the last couple of years. It could run client side and server side. And it's just an easy way. We chose TypeScript to be able to make it better for testing, for error checking, and to build on top of a large project. It works out really well for us. So what it is we implemented the new Haystack 4 deps and everything in here. And Gareth, why don't you go ahead and just demo this stuff?
Okay, thank you, Jason. Okay, right. So yeah, Haystack Core TypeScript. Let's just move this along. So I've got a few slides on the overview of what this library is. Then I finish off with a live code sandbox demo. You can find everything online. It's all open source if you go to github.com/J2in. Okay, so what this library is, it covers a wide range of Haystack technologies. Originally, it was looking at or based around actually the Haystack filter mechanism for a project we were working on, but kind of expanded from there. And you can use it in many, many different ways. It really is kind of a toolkit for working with Haystack data. TypeScript is a great language for us, especially coming from the world of JavaScript. But it's something you can use on the client and the server very, very easily, very, very well in the browser, or if you're on the server side using Node.js and Dino. So we've used it in both. I've used it in our cloud product, as I'll talk about that tomorrow. And we find actually it works really well for us. So we've developed all of our tooling around that. And now this is just something that we've open sourced to everyone. I think that the differentiator, because I mean, there's lots of Haystack libraries in different languages out there. This is the first one that I know of, especially in TypeScript, that implements defs and has support for defs. Not just kind of querying defs, but also the compilation of them as well. I'm going to be showing that later on. So the first library that we have is obviously Haystack Core. Haystack covers a multitude of different technologies. You've got the data model. Okay, so when we talk about the data model, we talk about all the core primitive Haystack types. So you've got things like grids, dicts, refs, booleans, and so forth. All of those are represented as a class. We also got support for Haystack Filters as well. Haystack Filters are a very simple query language for querying Haystack data. We've got the compilation of those Haystack filters as well as the execution. We've used this API in our own products to also kind of cross-compile to different database queries as well. The really nice thing about filters is that they're very simple to use and understand. And so it's nice to be able to actually use that in your own applications when you're trying to, have some way to actually query a backend database as well. We've got support for encoding all the major formats for Haystack data, for Zinc and Trio, and the new JSON format, the new JSON format for Haystack 4. There's another talk I'll be presenting with my colleague Radu on that tomorrow. We've got some really cool examples. It just won't be telling you what JSON is. And finally, of course, all the def normalization, compilation, and the querying is all built into Haystack Core. The second library we've got, the second project, and again, you can find these all on GitHub, is a complete Haystack unit database. The thing what we've done here is that all of the units that you have used to using are actually first-class TypeScript objects. Again, really making the best use of TypeScript, give you strong typing throughout so you can create robust software applications. Haystack End Client, this is a client networking library. It supports all the standard ops that you have in Haystack and includes some extra smarts as well. It's opinionated, this particular network library, especially around the use of watches. what we found in creating especially complicated user interface applications, ideally you might have 100 pieces of UI. When you're creating these applications, you're just interested in live data. You're not really too interested in what server-side watches are created and so forth. You're just interested in that live data. So we actually have automatic watch management built into this library. Typically, like, even if there's 100 pieces of UI, they're all basically requesting their own watches. Only one server-side watch will be created and managed for you. That's managed in the back end. Of course, you can manage that yourself using the lower level APIs here, but you don't have to. By default, we wanted something that just works and make it easy to work with live data. It has a pluggable CSRF token for cross-site request forgery token handling, because we realized that different Haystack servers will have different requirements on how that's handled. So we've got something there, so it's kind of extendable. It should work with any Haystack server, really, at the end of the day. Finally, to add something extra to the mix, now we use React a lot at J2. We think it's a really powerful way to create live, sophisticated software applications. One of the nice things that has changed in React is it's moved to a more functional design, a more functional set of APIs. So we've got something for creating rich HTML5 applications with Haystack data called Haystack React. And it's not as large as some of the other libraries, but these are just really nice convenience APIs. And I would say of all my years kind of creating these applications with live data, this is certainly the easiest API I've ever used for creating some live UI, because literally all the creation of the watch, the destruction of the server-side watch when you navigate away and the UI is destroyed, that's all handled for you with these hooks. It really is very, very simple. So these are the libraries we have together. We've got Haystack Core and units that kind of work together. And then we've got the network client library and the React library. We've got something new, which is experimental, which has literally come out last week, which is really cool, which is a TypeScript code generation tool. So you can convert from defs to TypeScript code, which is really, really cool. I'm going to be showing some of that in my next demo. So what we're going to do to kind of spice this up, we're going to be using Code Sandbox. Now, I'm going to actually get these URIs, this top URI, I'm going to put it in the chat, okay? And I want you can load up a browser and you can play along with me, because this is going to load in your browser a full Visual Studio Code IDE that you can actually run the applications there with code completion, everything there, the libraries are there. Don't worry, you can make a change to it. You won't affect my presentation. And this is something for you to play with beyond this presentation as well. And we wanted to do this just to try and make it a little bit more fun, a little bit more interactive, especially as we're all remote. So let me just switch over to that. So let me just bring this up, and I'm going to put this in the chat window here. This URI. I'm also going to put it on Attendify 2 and post that there. So again, you pay attention to what I'm doing, but it's there for you to to click and bring up. As I said, it won't affect my application here. It's all kind of APIs from this point. So if you're not a software developer, sorry about that, but we really wanted to kind of show you what this API can do. Right, so let's start from the top. This is really just using Haystack Core. It's not using the higher level APIs. We just wanted to kind of show you some of the core things you can do with the API. So we mentioned, first of all, that we have a granular type system in Haystack that consists of things like refs and strings and booleans and so forth. Of course, they all have their own class, but they also have a common interface, and that common interface is called hval. And I can create a string, a Haystack string here. I've just cast it to an hval just to kind of show you some of the common methods that you have. For instance, I can get the kind of data it is. I can convert it to Zinc, Axon as well. I can convert it to JSON, that's Haystack JSON, the new Haystack, which I'll be talking about tomorrow. All the primitive data types I have are immutable, things like strings and booleans. The collection types like lists and grids and dicts. They are, when you call new copy, they actually return you a new copy. They are mutable data structures. Everything else is immutable. This is quite cool down here. So this code here, which is I'm calling val.matches here, I can actually run Haystack filters against virtually any data structure with Haystack Core, which is nice. It's not just something to use with grids. What we wanted to do is, because, well, we've got the Haystack filter compiler, it'd be nice to kind of use that throughout elegantly through the whole API, especially if it runs correct. So you can call, you can see here, I'm actually calling a string here to see if it matches. And you can see the result here, true and false. If I actually change this here and I just save that, you can see it's live, change the screen here. This is all live coding here, and it's pretty cool stuff, the code sandbox. It's nice having this. Actually, you even get like code completion and stuff too while you type here, which is really, really super nice. Enables you to kind of play with it. So those are all the core Haystack values. What I'm going to do now is move on to all of the core values in Haystack Core. You can see here, I just import them from Haystack Core. I've got Celsius imported because that's a first class type. As I said, Haystack units, they're all Haystack objects as well, which is nice. And we can see we've got everything from here, from string, number, date, time, marker. You can see there's a make method for these types. That's because we also do interning as well to make it really nice and efficient. If you wanted to use this library, say on a smaller controller or something like that with Haystack data, we try to make this as memory efficient as we possibly can. So we have dict, list, and grid. And I forgot to turn off Slack. Whoopsie daisy. Let's move on to dicts here. So now Brian mentioned earlier on about a dict. That is essentially a record or an object that has key value pairs associated with it. So we have ID and dis here. This is actually how you can create one of those objects. And typically when you're creating these applications, you're working with these objects quite a lot. So one of the nice things here is I'm creating a site. And you notice I'm calling site.id here. Now a dict, if I get a dict, there are set methods here to kind of set new values here. And there are getters as well. But one of the nice things is what we've added is the ability to take advantage of the typing in TypeScript for working with all these different schemas and interfaces. So what I'm going to do, I'm just going to hop over to this TypeScript file. Now this TypeScript file was special. It was all generated from the defs database that Brian has been talking about here. So in particular, I always like to kind of start with site. But if you were to look at the database for site, so we've got year-built primary function area, you can see it extends entity and geoplace. You can actually see if I go to the official site and have a look, that actually is an entity and geoplace. So what we can do is actually take the defs database and actually create TypeScript code from that. And that's a really nice part of tooling. It makes it a lot easier to work with this. It also makes your code def-driven as well. So you're actually driving your application code from what you're using in defs, which I really like. It kind of adds a nice way to handle that. There's something called type guards, which is kind of an advanced TypeScript concept there for it as well, which is nice. But basically, what you can see here is that we can actually create these interfaces that make it nice and easy to work with defs and dicts here. So I can call .id and .dis without having to use those getters and setters. And it's a really nice validated way to work with that. So I've got another thing to show you here. I actually generated the whole defs database as TypeScript and then ran typedoc on it. And this code here actually shows you all of defs in TypeScript with Haystack Core. Isn't that nice? So if I actually go down and find site here and click on site, you can see I've got site, I've got all the properties for site here, okay? And I can see the hierarchy there. So it's, again, a really nice way to work with Haystack data. So let's move on from the dict interfaces. So before we kind of when developing this library, before we got onto that, we implemented support for grids, as you do when you create a Haystack library, and that added lots of smart things for working with Haystack data into grids here. So what I'm doing is I'm taking an entire project database, quite a big database actually here. And this first line here, you can see that I'm actually just running a site filter on that grid. I'm getting a list of all the display tags and outputting it here. So that's what you've got here. This second one is really useful. So you can see the inspect method. Again, I'm kind of using this builder pattern of chaining everything together. So you've got filter, you've got the columns I'm interested in, and then inspect. Of course, if you developed these applications before, you know, debugging information, it's really important. So what you can actually do is print out a table of any Haystack value to the JavaScript console just by calling inspect on it. And you can put in a comment there to kind of show you what you've got there. This actually works not just in a browser really well, it works well in Node.js and Dino on the server side too. So we think it's just a really nice thing, especially when you're writing script with Haystack data and you want to make the life a lot easier. We use, as I said, we use Haystack filters in lots of other creative ways. So, for instance, we have methods for matches and removing dicts from a grid, whether there's any and all. Down the bottom here, we've got something nice here for instance, showing the maximum square footage of all the sites in Richmond. So, slightly more complex query. Again, the whole filter API is supported. We've got site and GeoCities Richmond, and then we're getting the maximum area here that we're printing out. You can see it's got the nice pretty units too. Okay. So that's grids. Moving on, we're going to move on to defs. Now, so far, Brian has gone over some of the very high level concepts of defs. And defs are a great, really, really clever way of having machine readable relationships. And, you know, when I read the spec and coded it, you know, it's complicated stuff. It's nice to have a reference implementation, which was one of the main motivations for this library. So we've got multiple reference implementations in multiple languages that kind of prove out the technology. I have to stress when we go through this, you know, with this data here, I'm not using a kind of any kind of funny GraphDB database in the back end or anything like that. I'm just running this in code in JavaScript. So as well as it being machine readable, you don't need some sort of fancy backing database for Haystack data in some circumstances. Obviously, there's a scale issue there. But what I've done here is I've taken some of the new ideas for Haystack filters and implemented them in Haystack Core. Now, these will change because actually some of them are early straw man proposals. Some of these are not proposals at all in Haystack filters. So what I'm saying is that these are likely to change, okay? Don't count on them being there, but I thought it would be really nice to kind of show you what defs can do, especially when you're using Haystack filters, because Haystack filters, as I said before, I'm a big fan of them and they're very easy to work with. So what I wanted to show you is this first one here this is how you can query a grid to find all the things in a building that have electricity going into them, okay? Now, one of the criticisms of Haystack is the fact that the filters, the querying mechanism is too simple. Defs takes it to a new level. And I'm sure once we've kind of worked out one of those next challenges, as Brian said, and how precisely we want to implement it, it's going to be an awesome addition. I'm really excited about it. But you can see here, it's just asking for all the things in a building that input electricity here and printing out the nav name for them. The second one is a containment relationship here. So all the things contained in a particular record. The third one here, this is not using defs, it's actually using a wildcard operator here. So it's following the site ref. But again, it's just another way of expressing that containment relationship. The final one I've got down the bottom here is actually how you can do querying via a super type, in this case, geoplace. So remember now, when I had a look at site extends geoplace. That's how all of these tags appear here, like geoaddress, geocity, and geocoord, and so forth. So what you have here is when even though like those particular records, they've just got a site tag, okay, not a geoplace tag, I can actually query everything that's basically a subtype of geoplace. So it will pick up all sites. And that's why you're seeing all the sites here as well. And if there was anything else that was in a subtype of geoplace, it would show there also too. Okay, so that's a very, very powerful thing, a very powerful set of APIs to kind of query this data. And we're really excited about it. We fully acknowledge the fact that that will change over time. Just a few more things, just to show we've got the full unit database, so we can convert from Celsius to Fahrenheit, although of course we really want to say in Celsius. because it's the far superior unit. Then we've got multiplying units together, so multiplying miles by miles to get square miles. You can do all of that with this unit database, which is really nice. We've got support for Haystack. So the nice thing, so as I said, there's a talk about Haystack tomorrow. In this library, you actually have first-class support for Haystack. If you don't want to use Hstra and Hbool, and Jason does not like necessarily using those high-level types, you can just use a straight JavaScript string instead of an Hstra, or you can use a number if it hasn't got any units, or you can use a ref in Haystack format. So Haystack is a first-class citizen, yeah, obviously, of Haystack Core, which is really nice. So you have a choice when working with this data. It just is a natural part of the API, which makes it very elegant to use in a lot of cases. Just a few other little things with Haystack Core. We've got a filter builder just to make it nice and elegant, so you can build your Haystack filters with ease using a classic builder pattern. We've got the parsing framework here, and we use this in our cloud technology to compile a Haystack filter and then kind of cross-compile it to other database queries depending on your backend database. So that's pretty smart. What I'm doing here is I'm actually compiling a site and foo to a node tree, AST node tree, and then converting it back to a Haystack filter again, which is pretty cool. And then finally, last but not least, we have some support for Trio. There are many other technologies embedded in Haystack Core. We've actually got one where you can take a Haystack 4 Haystack filter and actually compile it down to a Haystack version 3 Haystack filter. In some cases, you need to requery, but actually that's quite nice if you've got kind of a legacy Haystack system and you want to start using Haystack 4, you can actually use this technology to start driving that forward, which we think is pretty nice. So as I said, there's some stuff to play with there. There's also another link I'll add to, which has got a few more things added to it, and I'm almost out of time, so I'm going to have to stop. But this is just another demo here, which shows it's kind of more of a live, you know, you can just type this, it's live, you can say, and this, and I could say equals Richmond. I can type Richmond here, and oh no, not this, GeoCity. That was my example I wanted to use, GeoCity. There we go. Nice and live. That's using Haystack Core and client. I faked out the client there so you can play with that. Again, I'll put that on this one here on the chat so you can play with it, and I'll add the other one to the chat also there, that so you can play with that also. So to conclude, that's the Haystack Core APIs. Now, I'd just like to shout out to J2, we're the makers of the Fin framework. Check us out. You can check out the source code on our GitHub repo. And if you want to reach out to me on LinkedIn, you can do so. There's my link there at the bottom. Okay, that's all I've got.